Section 5.3 is all about inequalities. Learned a lot of this before, so hopefully most of it's review. The vocabulary term for today is inequality, and it's a mathematical sentence that compares quantities that are not equal. And an inequality contains the symbols less than, greater than, less than or equal to, and greater than or equal to. And please make sure when you see those symbols, you know which one's which. When it points to the left, it's less than. And by pointing, I mean this kind of looks like an arrow. So if that helps you, left is less than. And when it points to the right, it's greater than. Next, I want you to write down some words that will help us as we write inequality statements. So when you see the less than symbol, you can use words like is less than or is fewer than. Those are all words that indicate we're talking about the less than symbol. For the greater than symbol, we have the words is greater than, is more than, or exceeds. Those will all be words that will help us as we're writing these inequality statements for greater than. Less than or equal to is the next symbol, and we use the words is less than or equal to, is no more than, or is at most. Those will all be for less than or equal to. And then finally for greater than or equal to, again the words is greater than or equal to, is no less than, or is at least. So make sure you write these down so that as we write our inequalities, we know which symbol we want to use. So let's write an inequality for each sentence. We have the DVD costs more than $15. And from the last slide, we just saw that more than meant the greater than symbol. So we're talking about a DVD. We need a variable, so we'll just use D. Costs more than $15. So D is greater than or equal to D is greater than 15. We have a dog weighs less than 50 pounds. So here's less than, and that is the less than symbol. So we're talking about a dog. I'll use D again. The dog weighs less than 50 pounds. So D is less than 50. On number 3, we have the height requirement is greater than or equal to 40 inches. So greater than or equal to. That's going to be the greater than or equal to symbol itself. We have the height requirement, so H, greater than or equal to 40 inches. For the height requirement is greater than or equal to 40 inches. The next type of example is that when you're given a value, you can tell whether an inequality is true or false. And this is very similar to when we used to check our solutions in equations. You are simply going to plug the value in for the variable and then determine if the inequality is true or false. So here we're going to take this -1 that's equal to t, and we're going to plug it in for t. So we're going to have 2 times -1, remember that's multiplication there, plus 8, and we're checking if that's greater than 7. So 2 times -1, that's -2 plus 8. Is that greater than 7? Well, -2 plus 8 is 6. Is 6 greater than 7? No, this is not true. 6 is not greater than 7, so we would write false. For the inequality 2t plus 8 greater than 7, t does not equal -1. That is not a solution that will work, or that is not a value that will work, so we write false. For number 5, very similar, we have p equals 40, so we're going to plug the 40 in for p and then solve. So 40 minus 42, is that less than or equal to -2? That's what we're asking ourselves. So 40 minus 42 is -2. Is -2 less than or equal to -2? Well, here's where you have to really pay attention to this symbol. That symbol says less than or equal to. Well, -2 is not less than -2, but it is equal to -2, and that's an option. Remember, this is less than or equal to. So it can be one or the other. It can be less than, or it can be equal to, and in this case it is equal to. So this is true. -2 is equal to -2. So the symbol less than or equal to will work. Last, we want to talk about graphing inequalities on number lines, and there are quite a few directions here, and some of these you may know, and some may seem obvious or simple to you, but I would like you to write these down. If you want to try to shorten the way it's written out, that's fine. So the further left your number, remember on a number line, the smaller its value. So if you think about a number line, the further left you go, the more negative you are, or the smaller the number is. When we graph on a number line, make sure your variable from the inequality is always on the left side. And that will help us with shading. We use a closed dot on the number line, which will look like this at our number when we're talking about less than or equal to and greater than or equal to. And what that means is that that point or that number is actually included. We use an open dot that will look like this when we have the symbols less than and greater than. That means that the point or the number is not included. And then finally, we want to make sure we're shading in the appropriate direction. And as long as your variable is on the left-hand side, you can kind of follow the arrow, which means look at the symbol. Less thans point to the left, and greater thans point to the right. So that's the way you can shade. But remember, that's only true if your variable is on the left side. So first we want to graph this inequality. We have a is greater than 6. So we have our variable on the left, so we can go ahead and just graph this inequality. The first thing we want to do is plot 6 in the middle of the number line. Next, we need to decide if we need an open circle or a closed circle. So we need to go back. We use a closed dot with less than or equal to and greater than or equal to, and an open dot with less than and greater than. Well, this is a greater than symbol, so we want an open dot. It means we're not actually including 6, but we're including all the other numbers either on the left or right side. Now, if a is going to be greater than 6, that means we're talking about all numbers greater than 6. So ask yourself, which side would that be? Would that be on the left side or the right side? Well, all of the numbers this way are greater than 6. And we want to make sure we shade all the way down the line like we're supposed to. So we're talking about numbers like 10, 50, 10,000.724. Those are all numbers that are greater than 6. And if you look at the way this symbol points, it looks like it's pointing to the right. Notice that greater than kind of looks like the greater than the end of an arrow pointing to the right. And since this inequality was solved with the variable on the left, we can look at that symbol and we know to shade to the right. So there are lots of ways to determine which way you're going to shade. It's easiest to just look at the symbol. If it's greater than, it points to the right, so we shade to the right. Next example, we have x is less than or equal to -1. So we want to start by plotting -1 in the middle of our number line. It is a less than or equal to symbol. If we go back 2 slides, we use a closed dot with less than or equal to and greater than or equal to. So that means that we are including -1 in the values that we talk about, so we're going to fill this dot in. Notice the difference between filling it in on this example and leaving it open on the previous. And now we're talking about all the numbers that are less than or equal to -1. Well, numbers that are less than -1, remember, smaller values are to the left on a number line. The further left you go, the smaller the value. But again, we have the inequality solved with x on the left-hand side. So you can kind of envision this as being an arrowhead, and it's pointing to the left. Less than points to the left, so we shade to the left. Go ahead and pause the video here. Try this example on your own. We have y greater than or equal to 5. So we're going to plot 5 on the number line in the middle. We're going to use a closed dot because we are including 5. It's greater than or equal to. And we're going to shade to the right. Again, we're talking about the values greater than or equal to 5. So everything to the right is going to be greater than or equal to 5. Or again, you can look at the way the symbol points. It looks like it's pointing to the right, so we shade to the right. And again, for the third time, that only works if the variable is on the left-hand side of the inequality. Now let's write an inequality for the graph. So this is kind of reverse. Here we're given the graph, we need to write the inequality, where on the previous three examples we were given the inequality and we had to draw the graph. So for this one, these are pretty simple. You need a variable and you need a number. So the variable goes on the left, the number on the right. Now we just need to know what symbol do we put in the middle. Well, first of all, you have to notice it's an open dot, which means it's just less than or greater than. This indicates less than or greater than, not with the line underneath. That would be if it were colored in. And we are coloring or shading to the left. That's less than. We're talking about numbers less than -2. So the answer here is x is less than -2. Here we have an inequality where we've got 3, it's shaded in, colored in dot, and we are shading to the right. So again, x and 3. And now we need to figure out which symbol goes in the middle. Well, because it's colored in, now it's less than or equal to or greater than or equal to. And because we shaded to the right, we're talking about values that are greater than or equal to 3. So x is greater than or equal to 3. In class, we'll work on worksheet 5.3.